Hello everybody. Today is functions and graphs and their transformations, day 2. So we're going to be looking at some prior information that we already know. So let's dig up that background knowledge and take a moment and write down what you feel in your own words the meaning of domain is, and then the meaning of what range is. If you need to, pause the video. All right. For me, the domain is that set of all x values, so it's all values that are represented by x. And for the range, it is all values represented by the y. We've done interval notation back in first semester. If you're excluding something, uh, values are represented by, what do we got? You said parentheses. You are correct. And if it's included, values are represented brackets. Okay, so open circles, we have parentheses, closed circles, brackets. All right. In numbers 1 through 4 here, our goal is to identify the domain and range of each graph and use it in interval notation. So we don't even have to do any transformations or anything like that. They're telling us, they're giving us this function right here, h of x equals 3 minus x squared, okay? And that's the graph for it, and we're looking at trying to have the domain and range. Well, the domain is the set of all x's. So x's go this way to the left, and x's go this way to the right. So when I look at it, how far to the left is this graph going? To me, it's going to keep going. It's going to keep going, keep going, keep going on forever. So the smallest value we have is negative infinity. And it's going to keep going, keep going, keep going to the right. So it's positive infinity for the other way. When you want to talk about range, we said it was the y values. So how far up does it go? How far down does it go? For me, the highest point, so the maximum point is right here, which went up 1, 2, 3. So the point was at 0, 3. So the highest value is 3. The lowest value we have is down here at negative infinity. Remember when writing it, it would be negative infinity, and then 3 is the maximum that we can get to. Notice I used a bracket because this dot right here was a closed circle. If it was an open circle, then we would change it. Okay. Number 2 here, h of x is the equal to the absolute value of x minus 2 minus 4. So we can see the shifts that they've had. All right, it went down 4, and then it went to the right 2. Okay. So we want to know what the domain and range is. Once again, the domain, how far left and how far right are values of x's. Looks like it's going on forever. So negative infinity to infinity. Our range, how far up, how far down. Well, to me, this is the lowest point, so here's our minimum. So we're over 2, down 4. So my value, my lowest value is that negative 4. And it's going to go on all the way up into infinity. How's it going so far? Hopefully okay. Domain and range is not meant to be hard, but you have to be able to interpret and understand the conceptual meaning of what it's doing. Okay. And the domain for the next one. So how far left, how far right. So it looks like it's here and it's going to go on forever this way. There is nothing here. This space here. Okay, that's a hole. There's no graph drawn there, and then it starts there and goes this way. This point here looks like it's at -2, 0, and this point over here looks like it's at 2, 0. So the graph is negative infinity and goes all the way to -2. Do you remember what symbol goes in between if you're combining two sets together? Ah, yes, the U for union. Then it picks up at 2, and this goes all the way until infinity. Okay, so that's where it's interpreting negative infinity to -2, picking back up at 2 to infinity. For the range, the smallest value looks like it's on this point here, and it's going up forever. Same thing. It doesn't go any lower than that. That's the height, so no matter which curve we pick there. So it looks like we're at 0, because that's the origin that it's at, and it's going up all the way into infinity. Number 4, here's the function right here, h of x equals 3 minus sine of x plus 4. Whether you know what the sine function looks like or not, I'm not going to ask you to do that right now, but the domain, how far to the left, how far to the right do we go? Looks like it's covering everything. There's no gaps or spaces, so you should know that's negative infinity to infinity. The range ends up going how far up or down, so it looks like this level here is the lowest. This looks like up here is the peak, that's the highest. So what is our range? Well, our lowest looks like it's a value of 1, because that's what this point is, and this is the height of 7. So it's 1, comma 7. Hopefully that's going okay. Now on the back side, we're going to do some other graphs. Number 5 through 10, it's something similar that we saw yesterday. And this time we're going to graph our original. We're then going to tell what the transformations are, and then we're going to graph the transformations, and then we're going to add the domain and range to the functions. Okay, so to me, the value we see is just an x. So what are we going to be drawing in here? If you said this is the linear model, you are correct. Okay, linear model meant a line. So we told you to draw the generic line, make it dotted, so it started at 0, 0, 1 up, 1 over, 1 up, 1 over, 1 up, 1 over, 1 up, 1 over 1, or down 1, down 1, down 1, down 1. Okay, there's the original. We need to figure out where we're moving it. So the number at the end here, this is the shift that goes up or down. So we went up 1, and this -2/3 is that shift that we're going to shrink or move. For me, you should know how to draw a line. So this is my y-intercept. So we're going to go up 1 and put a point there. This is our slope. So our slope goes down 2 over 3, down 2 over 3. So we go down 2 over 3, down 2 over 3, or go up 2 over 3, up 2 over 3, and make a solid line that'll go on forever. So the red is the new shifted line for us. The domain, all right? The domain, how far left and right they go. It's going forever in both directions, so it's negative infinity to infinity. A solid line like that will always be negative infinity to infinity, and we'll learn that coming up here. And then the range, how high and how low did it go? The range looks like it's the same thing from negative infinity to infinity. Okay. Number 6. Next model, we have f of x equals x plus 4 squared minus 3. So we see our squared feature right here. So what are we looking at? Quadratic, yes. So quadratic is our parabola shape. Start at 0, 0, and it goes up. And quadrant 2 also goes up. So there's our generic quadratic parabola to begin with. We need to look at our shifts. I said this number at the end goes up or down. So this is the down 3. If it's changing the x value on the inside, we shift it the opposite way. So instead of going right 4, we're going to go left 4. So we go to 0, 0. Okay. At 0, 0, we're going to then go down 3, 1, 2, 3, and we're going to go to the left 1, 2, 3, 4. There's our new starting value. And we're going to make that same U shape for that parabola. Yay, we did it. We need a domain and range, so how far left and how far right. If it's a regular parabola, once again, it's negative infinity to infinity. That's going to stay the same for parabolas. We need our range, so how low does it go? This is the lowest point, so it's the minimum. It's going up forever, so that'd be to infinity. This point we went over 4, and we went down 3, so we were at -4, -3. So we're starting at -3 is our lowest point, and we're going all the way to infinity. Hopefully this is going pretty smoothly for you, but we'll find out. Next one, we see that we have a square root and the variables underneath that. So we are looking at the square root function. All right, what does that look like? Somebody pointed out that it's kind of like an eyebrow. Let's go with it. Okay. So we need to figure out where our shifts are now. We have this -3 at the end, so that's the shift that's up or down. So we're going to go down 3 with that. And we have this minus sign in front. And what does the minus sign do in front of the x value? That's going to be the reflection. Okay. So I'm going to draw this function as going down 3. So if we went down 3, we'd be here. Okay. So a normal graph would look like this if we didn't have to reflect it. But in this case, we have to reflect over the x-axis. So over this x-axis, we need the mirror image. So if we were to reflect it down, the graph's going to look like that. So I'm going to erase the red dotted line because that has nothing to do with it. There's our function that we need. And now we could do the domain and range. The domain for this one depends on where is your starting value. So in this case, the starting value is the farthest to the left is this point, which to me is on the axis, which is 0. It's going on forever, going to the right, so that's why it's going to infinity. The range is how high up and how far down it goes. The highest point is here, which to me is down 1, 2, 3. So this point being 0, 3, there's your highest point at -3. And the goes on forever going downward. It's going to keep going down, 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 down to negative infinity. So the lowest is negative infinity to -3. All right, almost done here. All right, finish it up and then start on some independent practice yourself. Fourth one here, here's the function. What do we have? I see gives it away. If you said absolute value, you're correct. So we got the absolute value graph. We need our shifts. So we're changing the value of the x on the inside here. So we got to do the opposite of what we see there. So instead of going to the left 5, we're going to go to the right 5. And we have the minus sign out in front. So we just learned, if you haven't figured it out yet, that's the reflection that we're going to need to do. So our original graph is the absolute value, which is the V shape. So it starts at 0, 0 and goes up in quadrant 1, and it goes up together in quadrant 2. Okay, so we got that V shape. Now we need to make the shifts. So starting at 0, 0, we're going to go to the right 5, 1, 2, 3, 4, 5. Okay, and instead of drawing the V shape up like this, we need to reflect it over the x-axis here. So we're going to shift it and it's going to reflect down. Okay. Ta-da. Give us our domain and range. If you said negative infinity to infinity for domain, you're correct. It goes on forever. And for the range, the highest point is 0 here, and it goes down forever. So we go negative infinity to 0. Number 9 looks to me, I have a third power here. So this is the cubic. Okay. Under the cubic, we have that original graph that goes up, goes through 0, 0, and back up. There's the original. What is our shifts? Our shifts right here is this up 2, and we're shifting the x, so we keep talking about it. You do the opposite, so instead of left 3, you're going to go right 3. So starting at 0, 0, we're going to go up 2, and we're going to go right 3. There's our original starting point. We didn't have to reflect or do anything else like that, so we can make our shift like we need to. Okay, they should not overlap each other because it's not what needs to happen. The domain for the red line looks like it's going to the left forever and look like it's going to the right forever because it's going to keep maybe gradually, but it's going to keep gradually going to the left, gradually going to the right. For the range, it's going down forever and it's going up forever. So it goes from negative infinity to infinity. And number 10 is the rational equation. We have the variable of the x in the denominator, so we see the rational equation. So we need to then interpret and see what we do. There's no numbers on the end here, but there is a change in the x, so we do the opposite. So this is that left 1 instead of going right 1. The original uses the axes. The original rational function goes very close to the axes. Curves goes to the y. Same thing here, very close. Okay, so that's our original. How you interpret the next one, we said that we're shifting to the left 1. So instead of using this as our axis, we kind of use, and I'll use a different color, I'll use green. Our axis went left 1, so the new axis we're using is this green line here before we make the curves that we need. We didn't reflect over or do anything like that. So in this case, we shifted over a little bit, so we're very close to that green line, and then still very close to the x-axis because we didn't shift that way. And then same thing here, we're not crossing over the x-axis, and we get very close to the blue line, or that green dotted line that's not supposed to be there for it. So it was a shift to the left 1. The domain to me is the farthest is that negative infinity. And where did we go to? We went to this green line, which is negative 1. Then we have a gap space. So we got that union idea. And then we went from negative 1 over to infinity. I used brackets, but should I have? I'm going to say no to that because that part is not included. We're approaching that negative 1 line, but we're not actually touching that line, so we're not at negative 1. The range uses the 0. So how low does it go? It goes negative infinity, reaches all the way up to that axis of 0, but doesn't cross it. So use the parentheses again, and then we go from the 0 again over here up into infinity. This is probably the most challenging one to figure out, but if you're using that prior knowledge of all those other examples, you're okay with figuring out the domain and range. Thanks for listening, and have a great afternoon.